In this video, we're going to talk about another numerical description of our data, which is the measures of spread. Measures of spread, variability, or dispersion, or variation, these values represent how close or far the sample values are to or from each other. The lowest possible value of a measure of spread is 0 because that would mean there's no spread at all. And as the spread of the values increases, the value of the measure of spread would also increase. Let's take a look at what variation means. Variation does not specifically mean just the distance because it says there represent how close or far apart the sample values are. It just does not literally mean distance. For example, in this illustration, we have two different cash flows. If there is no variation in the cash flow, we will just have the same values that you have there, as you can see. However, in the second cash flow, we have different ones. We have small cash flows, regular cash flows, and actually even big cash flows. So if there's variation in the cash flows, meaning there is different amounts that goes in. And as you notice, the mean looks like they're the same. Another way of explaining variation is this. On the top portion of the cartoon, we see different sea creatures, different species for that matter. So there is variation in the creatures in the upper portion rather of the illustration. At the lower portion of the illustration, there is only rather one type of fish. So there is no variation in the types of fish actually there. So variation does not just literally mean the distance between the values. They may mean consistency. They may also mean whether the values are exactly the same or not. To show further how the measure of spread can be used, let's have this example. A testing lab wishes to test two experimental brands of outer paint to see how long each will last before fading. The testing lab makes 6 gallons of each pair to test. Different chemical agents are added to each group and only 6 cans are involved. For brand A, we have the following amounts, and for brand B, we have the following amounts. If we're going to use the measures of central tendency that we talked about before, the one that we can use here is the mean to represent all the values. And finding the mean for both brands, we will have the following value. As you can see, the mean number of months for each brand is 35. The mean of 35 months gives us the impression that brand A and brand B have the same performance. However, looking at their measure of spread might give us a different picture. Since the means are equal, like what you said a while ago, one might conclude that both brands of paint last equally well. However, when the datasets are examined graphically, a somewhat different conclusion might be drawn. As you can see in the following illustration, brand A and brand B are different in terms of its visual representation. Let's take a look. For brand A, as you might have noticed, the different data points that we have are a little bit far off spaced of each other. Since the different values are far off spaced for each other, they give off a different impression than the ones in B, wherein they are closer together, and we can say that this one is more consistent. Because more or less they would give similar values, but this one would be less consistent because the values can be quite different. We can describe the two brands even further as the following. For brand A, the data are dispersed, widespread, or scattered. We can also call it heterogeneous, large amount of variation, more variable, and like what we said a while ago, less consistent. For brand B, we can say that the data are clustered, there's narrow spread, it's homogeneous, small amount of variation, there's less variable, and it's more consistent. So, The measure of spread or the measure of variation does not deal just only with if the data are closer together or not. Although it's related, it's also more on the consistency, the heterogeneity or homogeneity of our data. So this can give us an even better picture than just giving the measure of central tendency. Let's have another example of how we can use both the measure of central tendency and the measure of variation. Given below are three groups, A, B, C, D, and their measures of central tendency and variation. Which of the following is the best group? Which of the following has more scores closer together or farther apart? Pause the video and try to answer the questions given. So let's see if your answers are correct. So if we're going to see which of the following is the best group, let's look at the different measures of central tendency. And as you can see, the highest that we have is group B or group D. So we can say that group B and group D are the best groups. However, let's take a look now at their measures of variation and see if there is an effect. So, in group B, the measure of variation is 6, while in group D, the measure of variation is 8. So, we can say that group B is more consistent compared to group D because apart from the two, this has a smaller measure of variation. So, that would mean that the scores of group B are much more nearer to 38, much more closer together and much more closer to 38 than compared to D. So, majority will say that group B is actually the best group because they have the highest measure of central tendency and a more consistent group of scores. Now, the other question, which of the following has more scores closer together, the answer is actually Group A because it has the smallest measure of variation. So, among all groups, it's Group A that has the scores that is closer together. And we can say that since this is the smallest, this is the most consistent group because it has all the scores closest together. And the last one is asked which ones are farther apart. And we can say that that is Group C because it has the largest measure of variation, which is 10. So we can say that this is our least consistent group because its scores are really far apart. So as you might have noticed, the measures of variability will help us even further describe the performance of our data apart from the measures of central tendency. And in practice, we really give not just the measure of central tendency, but also the measure of variation. As you can see now on the screen, we have actually 1, 2, 3, 4, 5 measures of variation to talk about. And let's start with that in the next video.